class, and today I'm going to talk to you about astronomy. I'm here to let you guys know about solar system formation, how it's formed, what causes it, and how it relates to us. So I'll get started with my first slide. And here we are as a summary. Throughout the evolution of mankind, we have made scientific leaps. Those scientific leaps have led to what we know now about the nature of the universe. Scientists have come to know how our solar system is formed from its very early stages in the scientific revolution till now. So we'll take it back, all the way back to the ancient Greece, and that's where it was the most mathematically influential society that we had during that time. So what they were coming up with has led to what we now know. It had to start somewhere. So back then is where it started, and if you know, that's people at that time believed that the Earth was the center of the universe, and the sun wasn't the center of the solar system, but the Earth was, and that is what's called as the geocentric model. And they also believed that the sky was static and unchanging. It wasn't until Nicholas Copernicus in the early 1500s where he discovered retrograde motion, and that is when you're on the Earth and you can see the planets change shape, but it's because of the Earth's rotating axis, and that's what causes it. He noticed that. And so he devised a system to make sense of what he saw, and he came up with the heliocentric model with the sun at the center of the solar system. But he wasn't taken serious because of the accepted dogma, because of the church and other things that influence the public's notion of what was right and what was wrong. So the next guy to make some observations was Tycho Brahe, and he observed a supernova explosion. At the time, they didn't know of supernovas, but he claimed it to be a new star, and he proved that the sky was not permanent and unchanging. He saw that things were going on out there by observing that observation. And it's going to help pave the way for the scientific revolution. So the next guy in the 1500s, or the early 1600s rather, is Galileo Galilei, and he's the one who invented the telescope. He discovered more about the system and the universe by seeing all the things he did through this telescope and the things he recorded. But for his recordings and what he saw, he was excommunicated by the church and wasn't able to leave his house. But it was a very important step in the scientific revolution. The next guy is Johannes Kepler, and these are the mathematicians who took those observations and applied them to mathematics. He used Brahe's observations to create mathematical calculations, like I said, and he'd come up with three planetary laws to describe our solar system. He showed that there was ellipses, orbital speed, orbital period, and distance. He took those observations and made them make sense mathematically. And the next guy to follow up on those observations was Sir Isaac Newton, and he developed three laws of motions himself, one involving inertia, mass, and acceleration. And for this third one, a lot of people know it, it's for every action there's an equal and opposite reaction. So, and he also came up with the theory of gravity, which was a monumental concept because it's what convinced astronomers that the heliocentric model was the correct model. His theory of gravity really changed people's way of thinking, and it was a mathematical concept that made sense to why the planets orbit the sun rather than the planets and the sun orbiting the Earth. So next we have what has come from all those discoveries and all those great minds, and today we have come to know that the inside the furnaces of stars are elements that are created, that are the ingredients for life. These elements are carbon, nitrogen, oxygen, iron. These are created in the furnaces in the middle of stars, and as stars grow older and older, they die. They eventually die in a way that's very magnificent. They explode. They will explode ginormously across space. And what this is called is a supernova. And it can occur in two ways: the sudden reignition of nuclear fusion in a degenerate star, a star that's dying, and then the gravitational collapse of the core of a massive star. So all that gravity will pull in, and once it gets to a certain critical level of all the chemicals and elements in there, it will cause it to explode on impact and releasing all of those elements into space. As you can see by this picture right here, that's what it looks like. This is a picture taken by a satellite in space. And what that causes is shock waves expand. Once that explosion happens, it expands from the supernova, and it can trigger the formation of new stars. Clouds of gas and dust become disturbed, causing them to form into solar systems. So these shock waves set out and they start this process from these dormant clouds of gas and dust in space. And what we see is that a solar system can be born through this. A supernova disturbs a cloud of gas and dust, like I said, and then as all of those things happen, that gas and dust begins to collapse and pull together. It by gravity, of course, and it forms a solar nebula. And the solar nebula begins to spin. The matter and the atoms, they continue to clump together, eventually forming a star in the center, which planets orbit the star because of gravity. So the sun and the matter and the atoms in the center become so hot and dense a star is formed. So while this nebula is spinning, it becomes so hot and dense in the middle that a star is born. And this spinning creates a stellar wind due to the gravitational pull of the sun. The planets orbit the sun. So now we have it right, and we're moving on to new frontiers. And we see that the icy matter settled in the outer regions. These are the outer planets because they're colder. So these are the ones that Jupiter and all those. And then the rocky material settles near the center of the solar system. And it settles there because the rocky material can survive there because of the heat. And of course the Earth, because of this, the chemistry of life becomes possible because of the Earth orbits the perfect distance from the sun. And we can tell the age of our solar system by studying meteorites. And these meteorites are leftovers from the early stages of the solar system. So scientists calculate that the solar system to be around 46 million years old. 46 million years old. And so I come to my conclusion. I hope that I have informed you today on solar system formation and what causes it. We've come to know that it's supernovas that cause it, and gravity that allows all of the objects to take place and allow us to be created, and it allows life to evolve on Earth. So that was all for you today, class, and thank you and have a great day.